This is chapter 12, section 1, tangent lines. Few sections of this chapter is going to be very definition heavy, less so math heavy. So these will go a little quick. So the first definition they give us is that of a tangent circle. And it says that a tangent circle is a line in a plane of a circle that intersects the circle exactly at one point. So what that means is that in this case they have a line here AB, and a line AB intersects this circle, but it only intersects the circle at one spot and one spot only on the circle, or one point and one point only on the circle, and that is called the tangency of the circle, where it's tangent to it. The point where the line intersects that one point in the circle is called the point of tangency. So we have line AB, and the point of tangency is point B. Again, a tangent circle is a line that intersects a circle such that it only intersects at one point on the circle. It could be a line, and it could also be a line segment, which leads to our first theorem. By the way, you won't be given any proofs or anything for this exam. I'm not giving any proofs. Theorem 12.1. It says that if a line is tangent to a circle, then the line is perpendicular to the radius at the point of tangency. So we have a tangent line. We're told that it's tangent. If it is tangent, line AB, then it intersects a point at P where AOP, the radius of the circle, is going to be perpendicular to the line AB. So OP, the radius, is perpendicular to the line AB. That's if we know that it's the point of tangency. They have a proof for it, but you're not going to be responsible for the proof. Here's a situation here. They give us an example right here. And we have like a kite, and they want to know what angle X is. Well, we're told in the problem that line LM, or segment LM, and segment NM are tangent to the circle at point L and at point M. Since I know that they're tangent, then I know that this degree is 90, I know that this degree is 90, and that this degree is already given to me as 117. I know that the sum of all angles inside of a quadrilateral is 360. So what the book does is it sums every angle up to 360. We know that the other two that are tangencies are 90 degrees. We have the 117. We add those together, subtract 297 from both sides, and we get that missing angle, which is 63. So down here, they give us a triangle. We're also told that ED is a point is tangent to the circle. So I know that angle D is 90 degrees. They also give me another angle. They don't give me a name for it, so we'll just say that it's we're given 38 degrees. We have a triangle, and we know that if we add those guys up, angle D plus 38 degrees plus X it's going to add up to 180 degrees because it's a triangle. So we have 90 plus 38 plus X equals 180. This is 128 plus X equals 180. We subtract 128 from both sides, and we got that X is equal to X is equal to 52 degrees. Pretty straightforward. Here, it's a little bit more trickier. They give us a tower, They give us a observation deck of the tower, and they want us to know what the distance is from the tower to the horizon. In this case, the horizon of the Earth. So, uh, we know that the total tower is 64 kilometers. This 64 kilometers is from the radius out. We know that we have the observation deck here. So here's the observation deck. Here's the radius of the Earth, basically. So we have the radius of the Earth plus the observation deck. We know that this point from the top of the observation deck to E is the point of tangency, so we know that this guy is 90 degrees, which means that this guy, since it's opposite of 90 degrees, this 0.45 kilometers plus the 64 is going to be the hypotenuse of this triangle, which is where we get this equation. 64 plus 0.25 squared, the hypotenuse, is equal to TE, which is the tangent line, plus 6400, which is the radius of the Earth, squared. So they squared both sides. They add the 64 plus the 0.45. They square it, subtract both of those guys from each other, square root it, and you get that TE, the distance from the observation deck to the horizon or the surface of the Earth, is 76 kilometers. So it says we have a distance of the horizontal that a person can see on a clear day from an airplane is 2 miles above the Earth, and the Earth radius is 4,000 miles. They want that distance that they can distance of the horizon that the person on a clear day can see the plane 2 miles above the Earth. So since a person is extremely small, it's considered the same thing as the horizon. So I don't want to draw this. So we have a person, which is the same thing as the horizon. We have the distance from we have two distances from the center. We have 4,000 miles here. We have 4,000 miles here. We also have an additional 2 miles here. And it's going to be from where this person here sees the airplane from the horizon. So this guy, since this is the tangent, this is the point of tangency to the horizon out, this would be the 90 degrees. This would be the hypotenuse. So so remember that c squared equals a squared plus b squared. This is the Pythagorean theorem. In this case, we have the hypotenuse plus a equals a squared plus b squared. So our hypotenuse is going to be 4,000 plus 2 squared is equal to 4,000 plus b squared. And then we're going to get this distance. This is the distance that we're looking for here. Whatever distance that is from the person looking out to the airplane right here. So 4,002 squared is a huge number. I'm not going to write it out there. Minus 4,000 squared gives me I'm not going to write the huge number out, so it's going to give me 16004 equals b squared, so we're going to square root that. So I get the distance is going to be 126.5 miles. 126.5 miles. So I square rooted the sum, or the squared the sum, which is 4,000, which is the radius of the Earth, plus 2 miles since the plane is 2 miles above. I subtracted the square of 4,000 from that, then I square rooted that answer. So 4,002 squared minus 4,000 squared is 16,004. I square rooted that to get the distance, which is 126.5 miles. Alright, so they give us another theorem down here, and it says that if a line in a plane of a circle is perpendicular to the radius at its endpoint of the circle, then the circle is tangent. So this is just the converse of 12.1 that says that if it's perpendicular at a point, then the line is tangent. So an example of this would be right here. They want me to find a radius. They tell me that it's perpendicular, so I know that this is a point of tangency. So since I know this is perpendicular, I know that this is a right triangle. So I can set this up using the Pythagorean theorem. So in this case it would be x plus 6 squared is equal to x squared plus 10 squared. I know that it's x plus 6 because it's opposite of the 90 degrees, so this is the hypotenuse. So x plus 6 squared is going to be x plus 6 plus x times x plus 6, which is x times x, which is x squared. X times, this is FOIL. X times 6, which is 6x plus 6x, which is 12x. And then 6 times 6, which is 36. And that's going to be equal to x squared. And 10 squared is 100, so plus 100. The x squareds cancels out. Subtract 36 from both sides. We have 12x is equal to 64. Divide that by 12. And then we get x is 5.3 bar. And that would be our radius. So radius is 5.3 bar. Alright, so they want to know if it's tangent. So what they're going to do is they're going to give me 3 sides to say they give us 3 sides of a triangle. They want to know if it's tangent or not. And the way that we know that it's tangent is that it fits the Pythagorean theorem. So that a squared plus b squared equals c squared. If they equal to each other, then I know that it's a Pythagorean theorem that holds true. Therefore, I know that it's a tangent line. So for problem 4, they give me that NL is 4, so 4 squared. They give me that ML is 24, so plus 24. I'm not sorry, they give me that as 7 from problem 4, 7 squared. And it should equal h squared, which is the hypotenuse. So if that's the case, if these two guys are equal on both sides, then we have a right triangle. Then I can say that it's a tangent, that ML is tangent to circle N. So 16 plus 49 equals to 64. If that's true, then it's tangent. This gives me 65. And it does not equal 64. So it is not tangent. Okay, so for this one, 12.3 says that if two segments of a circle share a common endpoint outside the circle, two tangent segments, then they are congruent. So we have segment AB, we have segment BC, and we're told that they're both tangent to each other. We're told that they're both tangent to each other. Since they're both tangent to each other, then I know that segment A, and they both hit B, I know that segment AB is congruent to BC. Oh my goodness. So in this case, I have these circles and they want me to find the perimeter. Notice that PX and PZ are both tangent to the same spot, so these two guys are 15. RZ and YR are tangent to each other, so I know that these both guys are 17. These two guys are tangent to each other, they're to Q, so I know these two guys are the same, so I can say, and they gave me that the perimeter is 88, so I can say 15 plus 15 plus 17 plus 17 plus x is equal to 88. Again, if px is 15, then I know that pz is also 15 because they're both tangent to the same point at p. If zr is 17, then I know that yr is also 17 because they're both tangent to the same point. If I know that qy is x, then I know that qx is also x because they're both tangent to the same point. And if I add all of those things up, that gives me the perimeter of 18. So this would be 30 plus 32 plus 2x equals 88. 64 plus 2x equals 88. I'm going to subtract 64 from both sides. So 2x is equal to 24. X is equal to 12. And that's my length of QY. Okay. So that's section 12.1. Hope you guys have a great rest of your day.